Okay, so welcome back. So now what we're going to do is we're going to go through a particular proof. We're going to go through a particular example before we do the proof for the lemma that we just went over. Okay, so now let's look at this example of a homogeneous linear system, right? So now what we're going to do is now it's already in echelon form. So what we're going to do is we're going to solve this and we're going to put it in vector notation. Okay, we're going to show how this works for this particular case. Okay, so I'm going to start over here. I'm going to just work on this. So we're going to solve for u here. So first of all, what are the leading variables? Well, the leading variables is u, y, and x. And hence the free variables are the ones that are not leading variables, and that would be z and v. Okay, so let's circle these. Okay, so v and z are free. So what we're going to do is we're going to solve for the leading variables in terms of the free variables. Okay, and see what we get. So let's do that. So first of all, we got x, y, z, u, and v. Right, so there's one of our vectors. Okay, so let's solve over here. So what do we get? We've got u is equal to negative v. Now we're going to back substitute into this one and then solve for y. So u is equal to negative v, so we get negative v, right? So let's rewrite this. So y plus z minus v equals 0, right? Now let's solve for the leading variable y. So y is going to equal 2v minus z. Okay, so there's our other equation. And now let's back substitute both of these into the first one, the top one. So we get we get x plus y, which is 2v minus z, plus 2z, u, which is negative v, so we're going to get minus v plus v equals 0. Well, right away we could simplify this because these two cancel with each other. And then this will cancel with one of those. And so we get x plus 2v plus z equals 0, which gives us what? X is going to equal what? Negative 2v minus z. And so what do we end up with? We end up with this, this, and that. And so now what we're going to do is we're going to use those three equations that we just solved for to rewrite any vector, right? To rewrite this system, right? This system in vector notation. So now how do we do that? Well, what do we got here? We got everything in terms of the free variables, right? So that means we're going to have one vector times v plus another vector times z. So let's erase these, right? And let's move it over. So we've got what? Now we've got y equals 2v minus z, and we've got x equals negative 2v minus z, right? Okay, so those are our three parametric equations, right? And so now we've got another vector times, oops, hold on. Yeah, that's right, v and z. So now we just have to fill in our two vectors, right? So how do we do that? Well, we're going to use these equations here, right? So every vector, x, y, z, u, v, we're going to be able to comprise of some linear combination of these two vectors with v and z. Okay, so now what are we going to do? Well, let's fill it in. So what for v here, x. Well, x has a v. So the coefficient here is -2. Y. Y has a v term. So it's going to be +2. Z. Z's free, right? So is there a z? Well, not here, so it's going to be 0, right? Because u equals -v. Okay, what else? So we got z, u. Well, u equals -v, so this is going to be -1. And then v, well, v is v. Right? V is free to be whatever it is, so we're going to have +1 there. So our vector is going to be -2, +2, 0, -1, and 1. Now what about z? What about this one? What about this vector? Okay, well let's do the same thing. Now z. Well, x has -z, so this is going to be -1. Y equals, well, it's going to be -z, so this is going to be -1. Z, well, z could be anything. Oops, so we're going to have +1. U, there's no z, so this is going to be 0, right? V, well, v is here, so this is going to be up to be 0 too. Okay, just like here, right? When we were talking about z, it's free. Z is one of the free variables. So we're going to be, when it comes to v, it's going to be 0. Over here, you know, v is one of the free variables. So when we're down here, it's going to be 0 because it's not, they're separate, right? Now, notice that to check, you can always check, go backwards. Do this, right? V negative, so x equals -2 times v plus -1 times z. What do you get? You get this. Y equals 2 times v minus, right? Minus z. Right there. Z equals 0 times v plus z. So z equals z, right? Because it's free. U equals -1 times v plus 0 times z, right? There you go, right there. And then finally, v equals v plus 0 times z, which equals v. So v equals v. Okay, so right. So that's what you should get. So again, there it is. We just checked and we made sure that we were correct. All right, so we showed how this is works for a particular system of linear equations that's in echelon form. Now what we're going to do is we're going to use proof by induction by showing that it works for this specific example, we're going to use proof by induction to show that this is going to work in all cases. Okay? Okay, so let's pick up that next time.